these communications are possible with geostationary satellite. Orbiting 36,000 kilometers above the ground, geostationary satellites rotate at the same speed as our planet, following its movement while always remaining above the same point on the equator. To an observer on the ground, this makes them seem perfectly motionless in the sky. In actual fact, they move at over 3 kilometers per second without using any fuel, maintaining their initial speed in the vacuum of space. In geostationary orbit, Eutelsat operates a fleet of satellites which cover 2/3 of the planet. Thanks to their position high in the sky, satellites are the essential complement to land-based networks. This enables them to avoid obstacles in the landscape and to connect an infinite number of sites across the Earth. Satellites could be called the network of all networks. They are the favoured means of broadcasting television programmes to households equipped with satellite dishes or through networks which themselves rely on satellite feeds. In addition to television, satellites also enable high-speed internet connection even in the most remote areas. A rocket can launch a satellite into space and reach its transfer orbit of 1,500 kilometers above the ground within 30 to 40 minutes. The satellite then deploys a section of its solar panels in order to provide a steady power supply during its travel in space. Engine propulsion is used to gradually make its orbit more circular until it describes a perfect circle and attains its final position in geostationary orbit. Once in position, the satellite fully deploys its solar panels and antennas, producing a wingspan of 40 meters. 3 to 4 weeks have passed since the satellite left Earth. Space vacuum, radiation, extreme thermal conditions of -150 to 150 degrees. Satellites are high-technology equipment designed to function for over 15 years in a hostile environment. All telecommunication satellites are built for the same purpose, to receive a ground signal and transmit it inside their coverage area. The signal is sent from a transmitting station, which can transport television programs or data, or establish an internet connection. In order to repeat the received signal across the entire coverage area, the satellite must re-amplify it and change its frequency. This is carried out by transponders, amplification tubes located between the satellite's reception and transmission antennas. All the equipment is fastened to a central pod. Radiated surfaces evacuate any heat produced, and heat shields insulate the satellite from the outside environment. In addition to the control systems, the pod houses the propulsion system and fuel tanks. This system maintains the satellite at its station and reduces disturbances related to the attraction of the Sun and the Moon and Earth's gravitational field. The 2 solar panels supply all the energy required for the satellite to fully function throughout its lifetime. This makes the satellite the most environmentally friendly means of communication. Each equinox, when the satellite moves to the Earth's shadow, rechargeable batteries take over. Approximately half an hour after the rocket takes off, the control center establishes the first communications with the satellite. All the equipment is permanently monitored from this point on, and every 2 weeks the propulsion system is actuated to keep the satellite in its station. A second control center monitors signal quality and ensures that each transmission station is using the correct frequencies and power levels in order to avoid any risk of interference. Television represents 3/4 of the traffic of satellites operated by Eutelsat. Present at every step in the video process, satellites transmit images to studios, exchange programs between broadcasters, transmit to satellite dishes and to cable and digital terrestrial headends. Thanks to satellites, landscapes and borders are no longer obstacles. Information can be broadcast everywhere in real time, even to the most isolated areas of the planet, offering all cultures a world audience. In the event of a disaster, the satellite takes over for damaged or destroyed ground networks to restore communications and coordinate emergency operations. On planes, at sea, on trains, and everywhere else that ground networks are absent or under-deployed, satellites provide access to all communication networks. Today, with the arrival of high-definition television and broadband development, man has never been more in need of space to communicate.